Now we can go through the same derivations for the arc cos function. So the first option we have is here. If we have theta is equal to inverse cos x, therefore we can write x is equal to cos of theta. And again, we can define the functions g of x and f of theta as theta is equal to g of x, which equals inverse cos of x, and x is equal to f of theta, which is equal to cos theta. So this is just similar to what we did in the previous video with the sine functions. So we can see that these are inverses because the inverse cos of the cos of theta will give us theta, and the cos of the inverse cos of x will give us the value of x. Now, because we know that these are inverse functions, we can use our little formula that we derived in our previous videos, and we can say that the g derivative of x is equal to 1 upon the f derivative of g of x. So we can see here that the value for our f derivative, well, our f of theta is cos of theta. So whenever we differentiate this, we're going to get the minus sign. But it's minus sign of the g of x. So the g of x is our inverse cos of x. So this is 1 upon minus the sine of the inverse cos of x. But we know the inverse cos of x is nothing other than theta. So this is minus 1 upon the sine of theta. And again, using our Pythagoras, this is minus 1 upon the root of 1 minus x squared. Now, the second method that we have is using the implicit differentiation. So again, we can say that x is equal to cos theta, and we can differentiate both sides of this. So when we differentiate this side here, we get dx by dx. When we differentiate this side explicitly with respect to x, we're going to get minus sine theta d theta by dx. So this left-hand side is going to give us 1 is equal to minus sine theta d theta by dx. So we can write d theta by dx is equal to minus 1 upon sine of theta, which is equal to minus 1 upon the root of 1 minus x squared. So this is the method you tend to see in a lot of books, and we know now why this works, because we're using implicit differentiation, which is really just our chain rule applied to two inverse functions, which is the same as doing this above. So finally, we can look at the same results for the arctan function. So let's look at those now. So finally, we can go through the same process for the arctan function. So we can write theta is equal to inverse tan of x, therefore x is equal to tan theta. We can generate the functions g of x and f of theta such that theta is equal to g of x is equal to inverse tan of x, and x is equal to f of theta equals tan of theta. So you can see that these functions g of x and f of theta are inverses, because we can write the inverse tan of the tan of theta gives us a value of theta, and the tan of the inverse tan of x gives us the value of x. Now, because we know they're inverses, then we can use this little formula here in order to generate the derivative of the arctan function, such that g derivative of x is equal to 1 upon f derivative of g of x. So the f derivative, well, that's going to be the derivative of our tan. So the derivative of tan is sec squared. And the value for our g of x is equal to the inverse tan. So that's sec squared inverse tan of x. Of course, before you can do this, you need to be able to differentiate the value of our tan theta, which we will look at in a different video. Now, this inverse tan of x, we can write that there as the inverse tan of x is equal to theta. So that's going to be sec squared theta. And we can use the trig identity, the sec squared theta is equal to 1 plus tan squared theta. So finally, we can write this as equal to 1 upon 1 plus x squared. Now the other method is using our implicit differentiation. We have x is equal to tan theta. We differentiate both sides. When we differentiate this side implicitly, we get sec squared d theta by dx. And then we can rewrite this as 1 upon sec squared. And again, we can use the identity. Sec squared is equal to 1 plus tan squared. And it can be written as 1 upon 1 plus x squared. So again, this is the method you tend to see written in books, and we know why this works now. So those are the three methods that we can use in order to work out the derivative of the arc, the inverse trig functions. We can use the little formula here, or we can use the implicit differentiation, or we can use the geometric technique, which we've seen in a previous video. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.